You are in a maze of twisty little passages, all different. You are on the edge of panic. That ogre standing over you is your unforgiving boss. How can you possibly implement all those game features you promised him? Launch is in 3 weeks. A truly horrible death seems imminent. Captain Firebase and his more capable, long-suffering sidekick, Coding Doug, to the rescue.
All right. Hello, everyone. I'm sorry, that was just entirely too silly. Oh well. Goedemiddag, Amsterdam. Oh, welcome or good afternoon, Amsterdam. I'm actually Justin, the Eng lead for the Firebase test lab team.
And I'm Doug Stevenson, developer advocate with the Firebase team. And thousands of developers have found the Firebase platform helpful to build their apps so far. At the time the Firebase platform was launched in 2016, the focus was only on iOS, Android, and web apps, with rich client libraries made available for all three platforms to make use of Firebase cloud services. However, for developers building mobile games, the native SDKs haven't been very helpful because games are commonly written or built with Unity or C++. Unity provides a whole different IDE and runtime for developing cross-platform games. Developers who are using are probably coding in C#, which does not really enjoy native support on iOS and Android. So the Firebase team believes that Firebase should be helpful for game developers, so they built additional SDKs for Unity and also for C++. So this means game developers can now build out their games using some of the best parts of Firebase. So if you're a game developer, I imagine you probably want to spend your time building worlds, creating snazzy special effects, perfecting smooth animations, and generally making your game fun to play. I'm also going to guess that you probably don't want to spend your time being bogged down building back-end infrastructure to support your game. And that's where Firebase can be helpful. And to illustrate this, we'll consult our friend, Hammy D. Hamster.
Welcome, Hammy. Well, Hammy is a space-traveling hamster encased in a metal ball shaped spaceship rolling around mazes in outer space, which is exactly what you'd expect from a futuristic hamster. Hammy is the star of Mecha Hamster, an open source game built by the Firebase team to demonstrate how to add features using Firebase to a Unity game. So let's take a look at some of those features. Now, Doug, I've found that during game development, one of the biggest pains that you have is having to rebuild and retest and redeploy your game every time you want to make some minor tweak to some small game setting. How can Firebase help with this?
Well, Firebase can help with this, and you can solve this problem pretty easily with Firebase Remote Config. Remote Config is a cloud service that lets you change the behavior and appearance of your app without requiring players to download your game and install updates. Instead, you code your app to use remote config parameters instead of hard coding constants. Then you can make live changes to those values in the Firebase console after your game is published. So in your game, you'll use a dictionary to define default values for all the named parameters that you might want to change. Then you pass that dictionary of defaults off to the Remote Config API. To check for updates to these parameters that may have changed in the console, you kick off a fetch, which completes asynchronously. So you can see it returns a task. That task represents the eventual completion of the fetch. Then when that task completes, you can activate the fetch values with another remote config method, or choose another time to make them available. Now, to get a hold of values in remote config, simply ask for them by name. So what we're going to do is take a look at this jump tile velocity parameter in action. So here in Mecha Hamster, we see a level that some users are complaining is too difficult or impossible to complete. The jump tile velocity parameter is set to 5 right now, so we probably want to bump that up to make it a bit easier. So what I can do is go to the remote config console, change the parameter to 8, and then publish the new value. Then when I relaunch the game, it'll fetch and apply the new value. So here's what it looks like now. And Hammy is able to clear the barriers more easily. So the game now appears to be pretty well calibrated at this point for the jump tile. But it's important to note, if you're going to be making changes like this, you should use a project that's used solely for development, because if you're experimenting on your actual players in production and you publish a value like 20 here, it could be very distracting and disconcerting for your users. Poor Hammy.
Whee! Yes, sorry for that horrible hamster impersonation. I found, Doug, that getting my players logged into my game, identified in my game, is just a royal pain. Authentication is really hard, just hard to get right. How does Firebase help?
Well, Firebase provides Firebase authentication, which provides backend services to let you authenticate the players in your game. And this is important because your players might be using multiple devices. So you want to be able to do things like save game state or achievements between them so your players can switch devices easily without losing any of their progress. So MechaHamster makes use of both anonymous and password-based login, as you can see here. But Firebase authentication also supports phone number authentication, Google, Facebook, Twitter, GitHub, and your own authentication system if you choose to integrate it. Now, for games, I think anonymous login is really important because it reduces the friction of getting players into your game and start saving their progress so they don't get held up on things like a login screen or being forced to reveal their identity before they trust you. And you can always upgrade an anonymous account to a fully identified account whenever they're ready.
So, once I've got my players logged into my game, now I want to store all the user content, all that custom content for them. How do I do that?
With that, you can use real-time database. So real-time database is a NoSQL data store whose defining characteristic is its ability to notify clients of updates to data in the database that changed in real time. The way that clients interact with the database is through listeners. So if you're interested in data in a particular location in the database, you add a listener there, then that listener will be called with the initial value of the contents of that location, followed by any updates. Then you remove the listener when you're done. With the Unity SDK, you just create a Firebase app object, use that to get a hold of a Firebase database object. From there, you can generate database reference objects. And these are like pointers to the path of the data that you're interested in. So once you have a reference, you can attach listeners to it. To be more specific, in the case of the Unity SDK, it's using a C# event handler, which has special syntax for adding and removing handlers. That plus equals operator right there is adding a handler to the list of handlers managed by the database reference. So this is not what the equivalent Android or iOS code looks like at all. The team decided it's very important to make C# programmers feel like they're at home by taking advantage of its best language features. So you'll see this sort of thing throughout the Firebase APIs on C#. Now here, the C# event handler is just a method that takes an argument that describes the data that's being changed. So we can reach into that, get a data snapshot object, and query it for typed data or the raw JSON for you to parse for yourself. So if you're looking through the source code here, this is what to look for.
So that takes care of storing my data, but I'm creating new content all the time, and I want my players to learn about that content as soon as possible. How do I let them know, even if they don't even have the game open?
Now, this is a job for Firebase Cloud Messaging. So with FCM, you can notify players when new content is available in your game. Now, there's two ways to send a message with FCM. First, from a backend that you control, so you can write code to send messages, or you can use a convenient UI in the Firebase console. MechaHamster is coded to accept messages composed at the console. So it also has two different kinds of messages that you can send, identified by custom attributes on the message. And I'll show you what that looks like. All notifications sent from the console will appear on the device just like any other device notification. The text here in the message text box describes what that looks like. MechaHamster defines a special kind of message that when you click on it will show more detail in the game when the player clicks the notification. So for this, it accepts a custom data with the name of the parameter is type and the text underscore message is the value. Then for the text of the message in the game, you can do some longer free-form text that you choose. So when this message is sent, it'll look something like this, and this is what it would look like on Android, so we can see the notification there. Then when the notification is clicked, it'll launch the game and send the player directly to the screen in the game that shows the extra information. So here we just have a promotion for a daily challenge. So the second type of message recognized by Mecha Hamster is a notification about a new bonus level. So if I'm the Mecha Hamster developer and I want to author a new level to publish immediately without requiring an app update, I can just build it, save it as a bonus map, then send a notification to my players that sends them directly to that level in the game. So the custom message here is bonus_map, and it takes a map ID, the ID that you created in the game, and some sort of descriptive text for that map.
So Firebase Cloud messaging is great for helping me stay in touch with my players. But I want to give my players a more social experience, one in which they can exchange messages or exchange content.
Yeah, so you can do that with Firebase invites. So with Firebase invites, it makes it really easy for you to share your game and its content, allow your users to share the game and its content with each other. That goes over email or SMS. So invitations are highly customizable. And in this bit of code, it's doing exactly that. So it's setting text to be used at various places during the invites. We have title text, message text, call to action, and so on. You'll notice it's also using remote config to grab the values of those strings for insertion. So you can you can change your invitation text simply by doing a remote config update. You can also attach some data to the invitation when you configure it. So when Mecha Hamster shares a map, it attaches the unique ID of the map to the level, and so when the invitation is received by the other player, when they click on it, it will show that custom level right away. And it's worth noting that Firebase Invites is built on top of Firebase Dynamic Links, which is a more generalized tool for sending players directly to content within your game. In Mecha Hamster, when a player builds a custom level, they'll do it like this, and then they can share it with others in their address book. So there's a share function. And what happens here is Firebase Invites provides the UI to make this happen. So you don't have to build any of this. This is provided for you. All you have to do is invoke the Invites API with the unique ID of the thing you want to share, and then the player can choose the recipients. Then the other player receives the invitation via a dynamic link, and you'll have to write a little code to handle that link as well.
So I have one more question. All this is great for adding new features to my game, but I want to understand how my players are playing my game. So, which parts of my game are they having trouble with? And conversely, which ones are they really engaging with?
Yeah, these things would be pretty important to know if you're a game developer. And with Google Analytics for Firebase, you can definitely track what your users are doing and populate a dashboard in the Firebase console that gives you insights into the demographics of your players and also their engagement with your game. So Firebase will track a bunch of events in your game without having to write a single line of code. Just put it in there and it starts collecting data immediately. But you can get deeper insights by defining custom events when they occur. So in this example, you'll see that in Mecha Hamster, there's a bunch of events. So when a map is started, when a map is created, when a map is shared, and so forth. With these, we can see a lot more about how players are actually engaging with the game. This is especially useful if your game has some sort of in-app purchase, because now you can track and figure out which players in your game are the big spenders and the ones that play your game the most. Those are the ones you really want to find out about. And there's a lot to see in the analytics dashboard, and I don't really have time to go over that right now, but you can get read-only access to a demo project called Flood It, and that's available for Android and iOS. You can actually download and play that game. You can get to the demo project by going to console.firebase.google.com and clicking on the Explore a Demo Project that's below the Add Project button. That will send you directly into what the console looks like if you were the Flood It developer. So inside, you'll see much of the analytics being captured by the game and summarized in the console. So again, you don't write any code, you don't do any configuration. This just starts appearing for your app when you publish it. If you're in the analytics and when you go to the demo project, be sure to try out Stream View, which gives you a real-time anonymized look at the players and the events they generate in the game. So this would actually be animated a little bit. So you'd see spots of people playing, and then if you click down here at a user snapshot, you'll get a random user stream of events. You can see in real time how players are actually playing your game. I went too far. But none of these features matter. So all of these Firebase products are great, but none of it matters if my game crashes all the time. So Justin, I need to know, how can I discover these issues in my game?
Well, Doug, that would involve some actual testing. So, for a high-quality game, you must do extensive testing on a wide variety of different devices. More about the latter part later. But testing games is hard. With regular applications, you can write instrumentation tests, or you can use our robocrawler. But games don't generally lend themselves to being tested automatically, at least not yet. Up until now, most game testing was manual. But earlier on this year, we announced at I/O support in Firebase Test Lab for game loops. So what is a game loop? Well, at its simplest, a game loop is a part of your game that simulates a user interacting with your game. You can see an example of a game loop for Mecha Hamster up there on the right. With game loops, you can automatically test for crashes or performance issues before they reach your players.
So this sounds pretty useful for testing my game, but I need to know, how do I code up one of these game tests?
All right, so now we're going to switch to, I knew I was going to trip over that. Oh, well. Okay, so going back here. All right, so it's actually pretty easy to add a game loop to a game. All you really need to do, at least one way you can do this, is to record all the user events for all the game objects and write it to a file, and then replay that file. That is exactly what we do for Mecha Hamster. So if we look at the code for Mecha Hamster here, we can see, and it might be a little hard to see, but we can see here that we have a flag, record gameplay, that if that flag is set to true, we use a class called gameplay recorder to write, or basically tee, the events, the user events, out into a file. Here is the class that does exactly that. And then we can grab that file and here add it as an asset of the game. Here it's stored under assets, hamster, of course, resources, replays. Now, Mecha Hamster, this is actually what the file looks like here. It's basically a JSON file with a list of events. Now, Mecha Hamster has a list of levels, and then for simplicity, each level here, this is part of the resources for the game, each level has one and only one game loop. And then, when Android starts up our game, it will pass what is known as an intent to the game. We can use that intent to trigger a game loop, or to register the fact that we want to trigger a game loop. And that's exactly what we do here. So here, we are testing the intent to see if it has a scenario number. If it does, we store it in this variable scenario number. And then later on, we can test for whether or not we have a scenario number, whether or not we want to run a game loop, which is exactly what we do here. And then we load that resource file and interpret the events in that file and run the game loop.
So if I have one of these game loops coded up, how do I actually run them?
Well, wait, where's the... Actually, running a game loop is pretty easy. You can trigger test loops locally by simply using an application called the Game Loop Manager. Now, the Game Loop Manager is an application that runs on the device, and it looks through the device for all the applications that have game loops associated with them. This one has just Mecha Hamster, so I'm going to actually run game loop number 4 here. And what it's going to do is it's going to load the game, and it's going to trigger this, and then, of course, you guys can't see that, but we actually have a crash on the device.
There's a crash on that device. Totally crashed.
You want to verify, Doug?
Yeah, I saw the crash.
All right. So what we'd like to do is we'd like to fix that crash. The trouble is, with Test Loop Manager, we don't have any detailed information about that. So what we're going to do here is we're going to run that same test inside of Firebase Test Lab. So to save time, I ran this test earlier for the same APK, and here is the crash. We can see that. If we open up this crash in Firebase Test Lab, and as we can see, we have an exception. And in fact, if we go look in the logs here, and I'm just going to quickly go search through the logs for a string that I know about, what we see here is that we seem to have a problem in player control of fixed update. So let's go look at the code. So over here, back in the code here, here's player controller, here's fixed update, and yes, there is the rather contrived exception. In fact, there are actually two exceptions here. There's a fatal exception and a non-fatal exception. We'll talk more about that a little bit later. So now what I'm going to do is I'm going to fix this, fixing meaning just comment out the exceptions, and then I'm going to save this, and I'm going to go back to my Unity SDK, and I'm just going to build it.
My bugs are always this easy to fix.
Yeah. So then I build this, and of course, that's going to take a little while. So we go back, and this is the APK that I built without those two lines in it earlier. And as we can see, no longer did it crash. Okay, and that one worked. All right. But you don't only find crashes when you run game loops. You can also find performance issues. So let's quickly look at the performance tab here. And what we see here are a bunch of different performance metrics, CPU, frames per second, memory, and network, tied, synchronized with the video, so that you can get some level of context about what is happening in your game as the CPU, memory, and network progress. Just as a quick example here, let's pick this spike, network spike, and take a look at what's happening in the video at that point. Well, it's loading, and sort of what you'd expect in terms of a large network spike. So now I'm going to test my game across a wide variety of different devices, and I can do that with Firebase Test Lab for Android. So all I need to do here is to go to the Test Lab tab here within Firebase, and then run a test. I choose to run a game loop here, and then I can load my latest APK for Mecha Hamster, and then I get to choose what scenarios to run here. So I'm going to choose the same scenario number 4 here, and then I'm going to click Continue, and here are all the devices that I can pick from. I have many devices here, many different API levels. I can just randomly click here. I even have a note 2 somewhere here. We have special fire protection in our data centers. And I have physical devices and I have virtual devices. You'll see also that we have API level 26 on virtual devices here. In general, we have the latest API levels, especially on virtual devices. So we will soon have API level 27, which is OMR1, as soon as it becomes available. So then, having picked all of these different devices, I click Continue. And then I can release my game into the wild.
Whoa, 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 whoa. Before you release, well, at least before I release a game, I always fear that I've made mistakes that somehow slip through the cracks. Like, no matter how much I've tested my game, it seems like there's always some sort of bug that crashes on my players in production, and I need to find a way what those are so I can fix them quickly, because if I don't, they'll just uninstall and then hate my game.
Well, Francis mentioned this morning in the keynote, Fabric became part of Google earlier on this year. And Fabric makes Crashlytics, and Crashlytics has support for Unity games. So all we need to do is to add support for Crashlytics to our game. We do this by downloading the Crashlytics SDK for Unity. And we do that by going to the link that's shown at the end. We then follow the instructions that involve importing the Crashlytics SDK as a custom package, and then dragging the Crashlytics game object into our game. And Doug, it's really that simple.
Yes, we did rehearse this ahead of time. So what we've seen today so far is that Firebase provides rich client SDKs and backend services to help build out your game. The backend services will scale up to meet the demand of your game and scale back down to 0 if necessary.
And we've also seen that adding game loops to your game can really help in terms of catching issues before they get into your players' hands. In addition, adding support for Crashlytics to your game will help you find those crashes that have somehow slipped through.
And if we advance the slide.
Yeah, we're having trouble advancing the slide.
Yes,
there
we
we
have
go.
slides.
Yes.
All right, so we have a bunch of resources for you to get started learning how to use Firebase for games. We have blogs and videos. We have documentation for the game loops. We have a link to Crash Lyrics for Unity, and there's a Firebase Slack, which is a community full of people who love Firebase. So please take a moment, take a picture of this if you want, and we will be in the Ask Firebase Lounge immediately after this if you have any questions.
All right, thank you, everybody. We'll see you in the lounge and at the after party. Thank you.